Welcome to this explainer. Today, we're going to completely transform how you view trigonometry. Look, if you've ever felt like trig is just this anxiety-inducing jumble of complex equations and impossible shapes, we are going to shift that perspective right here, right now. Together, we're going to see it for what it truly is, a beautiful, deeply logical, and just incredibly practical system. I mean, have you ever actually stopped to wonder how we figure out the height of a towering skyscraper? Or the exact width of a massive canyon? Or even the distance to a far-off star? Without ever, busting out a giant tape measure? The answer lies entirely in the hidden relationships between angles and lines. It's honestly like a superpower, letting us measure the unmeasurable. Okay, so here's our roadmap for today. We're going to start with the right triangle foundation, move on to mastering the unit circle, navigate it using the cast rule, apply the triangle method, and finally unlock some essential trigonometric identities. Let's dive in. Section 1, the right triangle foundation. All right, we're kicking our journey off grounded in a super familiar everyday shape. Think of the angle marked theta as your vantage point. In a right triangle, where one angle is exactly 90 degrees, the longest side is always the hypotenuse, for sure. But the other two sides, the opposite and the adjacent, they're labeled purely based on their relationship to our specific angle, theta. If you were to jump over to the other acute angle, the opposite and adjacent sides would literally just swap. It's all about where you're standing in the triangle. And that brings us to the holy grail, SOH CAH TOA. Rather than just some old high school memory trick, think of these three ratios as the absolute bedrock of physical reality. They dictate exactly how sides and angles scale together. SOH tells us that sine equals the opposite over the hypotenuse. CAH reminds us that cosine is the adjacent over the hypotenuse. And TOA means tangent is the opposite over the adjacent. These three simple ratios are the rules for literally everything we're building today. Moving right along, Section 2, Mastering the Unit Circle. So let's see what happens when we take that single triangle and just spin it a full 360 degrees. But wait, before we jump into the circle itself, we gotta contrast how we actually measure it. While you might be super used to 360 degrees, which honestly just divides a circle into 360 kind of arbitrary little pieces, in trigonometry we rely heavily on radians. Radians measure continuous rotation in relation to pi and the circle's actual circumference. So a full rotation isn't just 360 degrees, it's exactly 2 pi radians. It's just a much more natural way to measure the physical world. Now this is absolutely crucial. If we set the radius, which is the hypotenuse of any triangle we draw inside it, to exactly 1, the math simplifies so beautifully. Because of that simplicity, the x-coordinate of any point on this circle always represents the cosine of the angle, and the y-coordinate directly maps to the sine. No matter where you are in the rotation, from 0 all the way around to 2 pi radians, those x and y coordinates are mapping out your exact cosine and sine values. Boom. Section 3, Navigating Quadrants with Cast. Okay, managing all the positive and negative coordinates of the unit circle can seem like a total headache, I know, but there is a perfect cheat code for figuring out the signs. By starting in the bottom right corner, quadrant 4, and moving counterclockwise, we spell the word cast. This gives us an instant, super easy map of where our values are positive. In quadrant 4, the C tells us only cosine is positive. Moving up to quadrant 1, A means all of them are positive. Over in quadrant 2, S means only sine is positive. And down in quadrant 3, T means only tangent is positive. It's an incredibly fast way to check your work without memorizing dozens of negative signs. All right, Section 4, the triangle method. Let's actually take everything we've learned about the circle and our quadrants and use it. Here are two essential geometric tools, the 45-45-90 and the 30-60-90 special right triangles. Think of these not just as arbitrary shapes, but as the fundamental puzzle pieces making up the entire unit circle. If you know the side ratios of these two specific triangles, like the 1-1 square root of 2 ratio for the 45-degree triangle and the 1-2 square root of 3 ratio for the 30-60 triangle, you can solve almost any standard trig problem without even touching a calculator. Seriously, this simple 4-step recipe turns the whole overwhelming unit circle into a completely manageable process. First, you just pick the correct special triangle based on your angle. Second, you draw that triangle in the correct quadrant, pointing the hypotenuse toward the origin and making sure your signs match the quadrant. Third, you analyze the sides using SOH CAH TOA to find your ratio. And finally, you rationalize any square roots in the denominator and simplify. You're literally just drawing and analyzing a basic triangle. And finally, Section 5,
essential trigonometric identities.
Okay, we've arrived at what most people absolutely dread when they study math. But actually, scratch that. These are your ultimate cheat codes. Instead of viewing these as tedious formulas to blindly memorize, see them as a toolkit. This toolkit lets you bend and manipulate complex math into simpler, foundational pieces. For example, the reciprocal identities show us that cosecant is literally just 1 over sine. Secant is 1 over cosine. Cotangent is 1 over tangent. If an equation looks impossibly messy with cosecants and cotangents, you can just translate the whole thing back into the comfortable, familiar language of sine and cosine.
And building directly off the ancient Pythagorean theorem, you remember a squared plus b squared equals c squared, right? We get these 3 identities. Because our unit circle has a radius or hypotenuse of exactly 1, sine squared plus cosine squared always equals 1. It's like magic. These identities are incredibly powerful shortcuts for simplifying massive equations whenever you encounter squared trig terms. They let you collapse huge, intimidating parts of an equation down into just the number 1.
Wow, look how far we've come. We've gone from the basic opposite and adjacent sides of a simple little right triangle, mapped it all the way around a unit circle, and unlocked the very cheat codes of mathematics. So knowing that these simple building blocks govern everything from the structural engineering of the bridges we drive on to the orbital trajectory of the stars we look up at, how will you use this new perspective to decode the world around you? What unmeasurable problem will you measure next? Thanks so much for joining me on this explainer. Keep learning, and I'll see you next time.